Okay, so we've gone through all of our points of concurrency in a triangle. Today we're going to talk about what a mid-segment is. What do you think it has to do with a mid-segment? Okay. Okay, the middle of a triangle. That's a segment. Okay, mid makes me think of midpoint. Does it make you think of midpoint? Okay, so a mid segment is crazy, a segment that connects the midpoints, hence the name, of two sides of a triangle. It's a terrible triangle. So here would be an example. Okay, here is a midpoint, and then I connect it. There, this purple segment that I'm highlighting yellow, that is a mid segment. A segment that joins our midpoints of two of our sides. So how many mid segments would we be able to draw if I put the midpoints of all three sides? How many? Three. We would have three mid segments because we could draw this one here. We can make a cute little picture like that. Okay, and really, it has some really nice properties. Okay, so here's our theorem. You ready? It tells us two things. If we have a mid segment, this guy right here in pink, our mid segment has two properties. Number one, it's going to be parallel to that third side. Number two, it's going to be half as long. Okay. So, first of all, we're parallel. Second of all, it's going to be half the length of that side it's parallel to. That's it. Okay. So we just need to be able to say, hey, that's a mid segment. I know it's parallel, and I know it's half the size of that parallel side. Okay. So what I would like you to do is draw this picture right here. We're gonna draw a couple pictures, so draw it small. Okay. I want you to draw a mid segment, and I want you to label that mid segment like 5. That's the prettiest picture. However, if I'm asking you for, hey, what's the value of X? What would you tell me? Yeah. How'd Nora get that? Well, half of 5 would be 2.5.
No, like,
So can you be more specific?
that is half.
So maybe if I label this A, B, C, D, E, you're saying BE is half the length of CD.
Yeah.
What else do we know about BE and CD? We know that they're parallel. want you to draw this picture. That's not. I didn't want the right triangle, that's why I redrew it. Clark asked, could we just double 7x and set them equal to each other? Yeah, that's what I would do. I would rather double something than cut something in half in an algebra problem, wouldn't you? Okay. So we know that 17x is twice as long as that mid segment. So let's take the mid segment, 7x, and double it. Okay. Now, luckily, our mid segment is only one term. If it was like addition or subtraction of two terms, we would need to make sure that that 2 gets distributed. You know what I'm saying there? Okay, but right now we're good like this. So we have 14x equals 17x minus 18. What'd you say, Braden? 3x equals 18. So x equals 6. So we know from that our mid segment would be 42, which would mean the side of our triangle would be